Hello everybody, Mr. Kelly here. I was looking through my house on ways that I could try and teach you guys about circuits, and I found this game in my closet that's a pretty clever way of showing circuits. The game is called Circuit Maze, and it has this pretty easy setup here. So this is my power source. This is my battery, and in order to have a continuous flow of the electrons, I need to have a complete loop or a complete circle. Right now there's this gap between my start and my end. So it starts to flow, but it's not going to go anywhere because there's nowhere for the electrons to go. So I'm going to show you a simple circuit, positive going towards the negative. Um, and here is one continuous loop. So I have my light bulb that is lit up. You can see that there is a complete flow. There's a complete circle. So that's all well and good. Let's show a series circuit. Let me just pull these apart. And pop in another light right here. And you can see that these ones are significantly dimmer than the yellow light that I just had. And the reason why is, I like to think of it like water. These are both filling up with the water that's coming from here. So they're having to share their own water because it's still the same loop. This is still one continuous loop. So these two are sharing right now. Let's say I wanted to have it be that they're full capacity in terms of light. How could I do that? So let's take a look at that. So I'm going to set it up right here to show this is what's going to be called parallel. And once they're in parallel, you're going to see that both of them have their own flow of electricity. So there's a loop here and a loop here. And so now these ones are both significantly brighter than they were when they were in series. And these are running essentially parallel one to another, and they have their own flow of electricity. So just a little bit of a model to help you guys out to see the differences between series and parallel. All right, so let's take a look at some of the math behind solving a parallel circuit. So here's an example of a parallel circuit. You can see that they are actually parallel one to another, just like you would think of a railroad track as running parallel. These two resistors are running parallel one to another. And we can see that the flow of the electrons goes from our battery through each loop. So each one has their own continuous loop or flow of electrons, just like we saw with the circuit maze demo. So first off, let's figure out the voltage. Right now in our example, we have a 100 volt battery, which means that the voltage is the same throughout. So resistor 1 is getting 100 volts, resistor 2 is also getting 100 volts, and the total, we don't add these together, it's just 100. So that's probably our simplest solution right now. The next thing we got to do is we got to solve for current. And so that's when the wheel comes in handy. So here is my wheel. And right now I have voltage and I have resistance. I don't have power. We haven't talked about that too much. I'm not worried about power. So I'm going to use this formula right here. Voltage divided by resistance. So 100, which is my voltage, divided by my resistor 1 has a resistance of 2 ohms. So 100 divided by 2 is equal to 50, and it's current, so that's amps. We're going to use A for amps. The next one is resistor 2. It has a resistance of 6 ohms. So 100 volts divided by 6 ohms and that's where I'm going to have to use my calculator, is 100 divided by 6, and I get 16.66 repeating. I'm going to go ahead and, oh, it's getting a little blurry here. I'm going to go ahead and round that to 2 decimal places, 16.67 amps. In order to figure out current, it's very simple. It's just adding them together. So 50 amps. Let's see if I can get the calculator to work again. So 50 plus 16.67, and I get 66.67 total amps. 66.67 total amps. The next thing is the resistance, and this is where it gets tricky. We're going to start to have to use a formula for this, and the formula is 1 over RT, which is R total, is equal to 1 over R1, so that's my first resistance, plus my second resistance, 1 over R2. So when I'm figuring out the resistance, so R has a resistance of 2 ohms, 6 is for resistance number 2. I can't just put them and add them together. This is not in series. We are now in parallel. So I can't just go 6 plus 2 is 8. That would be incorrect. That's wrong. What I have to do is I have to do 1 over 2, just like the formula shows, 1 over 2, which gives me 0.5, and then 1 over 6, which is going to give me, we do it on the calculator, 1 divided by 6 to give me 0.166 repeating. So I'm going to go ahead and round that to 0.167. And the next thing I'm going to do is I'm going to add those two up. 0.167 plus 0.5, and I get 0.667, but that's not the total, remember, because the total is 1 over RT, or 1 over R total. So my R total is 0.667. I have to divide with 1 on top. So I do 1 divided by 0.667, and I get basically 1.5 ohms as my total resistance. So you can see it's a little more complicated when we're doing it in parallel. So I hope that helps. If you guys have any questions, please feel free to contact one of us as physical science teachers, and we'll be happy to work with you and help you out on what you need. So have a good day.